Hello, and it's time for another Let's Make It. And this week, I'm going to talk about some things that I mentioned last week, actually, about some LCD screens. Before we jump into that, I do a couple of housekeeping things. I want to thank everybody for spreading the word about us. The growth of this show has been amazing to me. I just love the fact that so many people are involved in this kind of a hobby, and it's very fun. But this is the show we talk about making things, and we focus a lot on Arduinos and Raspberry Pis and things like that. And we're starting to do a little bit more stuff outside of just the electronics, and more in the making of things that generally have electronics involved in them. But we're expanding that out a little bit. But we do talking a lot about Arduinos and things like that. Things that are little tiny PC board type products that you can build in your home and have some fun with and learn and make simple things. So that's what this show is all about. We record a show every Monday night at 9 p.m. And you can come and watch us live, get in the chat room and chat with us. It's a little bit light in there tonight. I have like 2 people in there, and they're being kind of quiet. So, but we can also take your phone calls and all that kind of stuff too. But tonight we're going to keep this kind of focused on the LCD because this is something that I think needs some explanation from somewhere. All right, so before I do that, I wanted to show you 2 other things tonight, but one of them is not working, but I'm going to show you the other one. I have 2 touchscreen-based systems. One of them is on a Raspberry Pi, which is the one that for some reason is not working, and that has been the most difficult one to get working because the drivers are all different. So it comes back to this whole thing of these LCDs. There's not like a documented standard anywhere for anything. So we'll talk about that a little bit. But the other one that I did get working, and I'm still up in the air if I'm going to keep it as it is or modify it a little bit, is on the UUDO. I got an UUDO a while back, and I am starting to work on some programs that the UUDO would run, because UUDO basically is 2 different CPU systems, one of them being the same CPU that's in the Arduino Do. So we can do everything that we do with our button boards and everything with all the timing issues that we'd had on the Raspberry Pi. We can use the Arduino Do and do everything that we do with our libraries that we already have, but use a quad-core Unix-based system to do the actual running of the system and do the maintenance. So it's truly a multitasking environment, not just Unix multitasking, but also we can have one CPU managing just the displays and the buttons, which gives us a lot more capability. We don't have to worry about waiting for network activity and things like that. So that's something I'm playing with. But I have the choice of running it either a Ubuntu Linux on it or running Android on it. At the moment, I have Android running on it, but I want to show you a little bit about the touchscreen and stuff like that. Then we're going to hop over and talk about the regular LCD. So let's hop over there real quick. And what you're seeing right now, as I move over, because I'm still using this funny product camera, is the display. And you're seeing this is actually the UUDO. I'll move this out of the way, and hopefully the light comes back up. There we go. That's the UUDO. So you under right there. Let me see if I can point to it. Right there is the Arduino chip, or the chip that runs the Arduino Do, same thing. And then under this heat sink, which you can tell hard to tell it's a heat sink, but that is a heat sink, is the quad core box. And you can see this also has Wi-Fi and audio built in, and it has a monitor built in because I'm holding the monitor in my hand right now, and a bunch of other things that are basically very, very much PC-like. But what this is, if the camera readjusts itself, is a touchscreen that's running Android. So there's the Android menu, and you see the camera keeps adjusting because of the light. But I have the Android menu, go back to home. So you have this general Android interface that people are used to on their phone, which is one of the things I'm leaning towards. Is it's quick to develop with, and it's user friendly as far as what the user is used to, because a lot of people have Android phones and they're used to this type of interface versus running the Unix touch interface, which is basically X Windows on touch, which isn't overly intuitive. X Windows is not designed to be touch where Android is. The disadvantage to Android, at least from my perspective, is that when you're running Unix, it allows you to program the Arduino code right from the Unix box or the Unix operating system. So I could actually upload in the background new code to the Arduino without anybody even knowing it, and just make it an automatic thing, like an automatic update. Or even if they, not necessarily automatic, but they can hit a button and say, I want to update it. Where with the code that runs Android, there is no IDE environment that runs on Android for the Arduino. So I don't have, without some custom coding, maybe possibly, I don't have any way to upload, like in the background, a new sketch to the Arduino part of the board versus like I can with Unix. So, but I'm still leaning very heavy towards Android, just from the fact that it's user friendly. That's the most important part. We have to work through some other update processes throughout this, but that seems like it's easy. Plus, the development tools for Android, I already know how to develop for Android, so it's pretty easy to develop. There are some things I want to do with this that are not typical Android, and one of them being I want to be able to boot without coming through this screen and bring the program up directly. I don't mind if they get back to the interface, because that's okay. But what I would like to do is when it comes up, to go right into my program. So some automatic things, skipping the boot cycle, some of the boot cycle things. I know it can be done because I've seen other embedded Android systems that do that. I just don't know how to do that. That's something that's really low level, and I've never investigated. So it's going to be a learning experience. Where on Unix, I can do that pretty easy because I know the Unix environment very well. All right, so that is the UUDO. And let me grab a couple things here real quick as I head back over to the other side. There goes my hand. And here I am coming back. Okay. So, like I said, today we want to talk about LCDs. So the most common question I give LCDs is they've bought an LCD and they can't figure out how to get it to work with the Arduino. Well, there's a lot of reasons that could be. So I want to go through a little bit. There's a lot of confusion over some of the terminology. I actually took some notes here. I want to make sure that I can get all the notes out as well, because I went through some of my old emails and things like that. Let me get my notes here. So I get this question sometimes like, well, they got an LCD 2004. Well, that's a pretty generic. That's not really a part number. What that basically means is they got an LCD that's 20 wide and 4 lines high. So this is one of those. That's not telling me who the manufacturer is, though, or what's on the back of it, like how's it interfacing and things like that. That's just a generic term saying I have a 4-line, 20-character display that I want to hook up. So there could be a parallel interface, which almost all LCDs like that are. So I mean, my parallel is a little easier to tell on this one. Is see all these holes at the top that basically allows you to connect all those signals into it, and it takes more than one input at a time. So basically, it can be either a 4 or an 8-bit input. So rather than serial where it's 1 bit at a time, you basically set up the pins and you clock the pins. So when it reads it in, it's reading in either 4 or 8 bits at a time. So it's definitely a faster way of doing it through serial. But this is how they come by default. They come like this. Back in my old days of the PIC chips, it's where you determined how many pins you need on your PIC chip. Is what are you trying to do with it? So the problem with these parallel ones is it takes up so many pins. Like I said, there's 4 or 8. Most people use 4. And then there is also a read-write pin. There's a configuration pin there. Let me go through the pins here. I'll go through all the different ones that are here. Let's see. Page number 9 on this one. And actually, I'll go over here and I'll show you all the different pins that they are as well. Let me hop over to the computer as I get down here. Actually, it's page 19 in this one. So right here's the pins that you got to use. So pin number 1 is ground. So that's an obvious. You need ground and power. Those two are kind of determined anyway. So then pin number 2 is your power. Pin number 3 is your contrast adjustment, which we don't typically use a pin off the Arduino for that. It's possible to do that, but it's not the most common way. Typically, it's just some kind of potentiometer. That's what we basically use, and we'll show you that. Then you have the RS pin, which determines, are you writing to the data or are you writing to the instructions? So you're writing to the screen or are you going to give it instructions? Then you have the read-write selection, so you're reading or writing. And then you have the enable signal. And then you have your 4 or your 8 bits of data. So let's add this up off the pins that we're talking about off the Arduino. So RS, RW, and E are typically a pin, and so are DB 0 through 3 or 0 through 7. So let's just say you're doing a 4-bit, which is most common, LCD. So off the Arduino, you're going to be using 7 pins. So with an Arduino that only has 11 pins that are really usable, then you are really getting down there as far as how many pins you have left on your Arduino Uno, for example. So what's the most common thing to do is we use a serial-based interface, which is typically I2C. There are plenty of libraries out there for the parallel interface, and it comes actually in the code. When you install your IDE, you can go into examples and get the LCD interface example, and it should work right off with the parallel interface. Make sure your pins are all put in the right place and everything, but out of the box, that's the way it should work. However, the most common way people use it on the Arduino is using I2C. And I2C is a serial interface that is very fast, and you have to somehow convert that serial interface into the parallel interface that the LCD wants, which is where the problem comes in. There's not really a standard. In fact, I'm going to show you some different things here that makes it even more confusing. But before we do that, let's talk a little bit about I2C. We talked about I2C in the past, but here is the Wikipedia article. I'm going to put all this stuff in the notes so you can go read about what I2C is. This is a page about I2C. It's on Wikipedia, and it's a little detailed and probably over some people's heads, but it gives you the basic idea of what I2C is, some things that are required for pull-up resistors and all that kind of stuff. So it's a good read. But then there's also, here's the problem with I2C. I2C is limited by its addressing. So I2C itself is a 7-bit or a 10-bit addressing. Most common out there is 7-bit, which that provides 128 theoretical addresses, but some of them are reserved. So you can't use, here, how many on the reserved right here? Let's see, 1, 2, 3, 4, 5. It's like 6 or 7 addresses are reserved you can't use. So you still got like 120 addresses that you can use. And that's assuming that you have a 7-bit address. But what some of these chip manufacturers do, and we're going to go show you that in a second here, is they don't want to use up all the pins. They want to, because if you use all 5 address pins, it requires 5 pins on their physical chip, which makes the chip bigger, more sensitive to produce, the whole way down the line. So their whole goal is to keep the pin count as low as possible. So most of them, and I would say probably more than 90%, 95% of them, only supply you 3 pins to access to set the address instead of the 7 pins that they should be able to do for addressing. So what they've done is they've kind of fixed the other addresses to be a particular address, and you can adjust like 3 of the pins. So let me go and say this. That's a problem, because you got to know how the inside of the chip is wired to know what the address is. Fortunately, most of these chips that are used to do this are made by one company, but their problem is, I'm going to go show you this as well. The problem with that is, let's see, I think this is the ones on page 9. Yep, here it is, page 9. Okay, so the problem with that is if you look at this is this chip we're talking about, and it's by NXP. They have 2 versions of the chip. They have a PCF 8574 and a PCF 8574A. The only difference between them is the addresses. So here they show you what they get. They give you access to these pins, A0, A1, and A2 on both chips. But look at the first 4 numbers right here. They don't give you access to this information. They fix it internally. So the standard PCF 8574 is going to be 0, 1, 0, 0, and then whatever 3 pins are assigned to the chip. The PC 8574A is going to be 0, 1, 1, 1, and then whatever 3 pins are assigned to the chip. So they look exactly the same. The chips, you can't tell them apart. So if you look at it without looking at the part number, you're going to think it's the same chip, but the addressing is going to be different. So this is where the confusion comes in, is it's the addressing. And the problem is these people that manufacture, these companies that manufacture these boards, I'm going to call them a backpack board, because basically I can show you one here. Let me go to the camera over here. Let me get the UUDO out of the way. All right, so the UUDO's out. So this thing right there on the back is the backpack. And there's a bunch of companies that make this. This is a YW robot. And there is SaneSmart makes one. And the problem is the documentation for these backpack boards is very, very poor. In fact, it's hard to find. SaneSmart is very, very hard to find. The YW robot I have found places. But what you're going to see here is that there's no way to set the address on this board. You see the chip, but there's there's nothing telling you what the address is. So unless you know how they wire the pins up for the address, you don't know what the address is. And each company that manufactures these does a little bit different. So what you see in the back of this is you see the chip, and then you see the potentiometer I mentioned before. That's your adjustment for the contrast. And then you see this little thing on the end down here, which provides power to the backlight. Well, when it's in a box, it's kind of hard to reach that power for the backlight. However, most new or recent displays allow you to turn off and on the backlight via command. So that's not really even needed anymore. So this is kind of an extra thing that's not really needed. But by looking at this, you can't tell what the address is. And that's the problem. You get a different manufacturer come in, or a different one from a different manufacturer. What address did they use? So what I'm going to show you here in a little bit is a sketch set I'm going to put out in the show notes that you can run, plug in your display, and it'll tell you what the address is. So that's what that is. So because of this, we actually developed our own backpack. So we have our own now, which this is not a sales thing. I was going to show you what we did a little different. You see there, you can set the address. By default, it's set to 000, so we know what the address is by default. And in this particular one, I actually installed the transistor up here on the top left that allows you to turn the power off and on to the LCD. That is not normally installed unless by default it doesn't come like that. It comes like the other one, but it's always on because most modern LCDs. We do have a couple LCDs that we use that do not have the intelligence. That's why that chip is there for this particular one. But it looks just like the other one. It's actually using the exact same chip as the other one. But we just provided you the ability to set the address, and there's a few other features on it that we've added as well, and rearranged some of the parts and how they lay out. But this is exactly the same as the other ones. This is ours that we created. So you can see they're all so similar, and we're all using the same chip. So what you don't know is what address does the manufacturer use. So what I'm going to do now is I'm going to show you what most commonly happens to people. Hang on a second. I'm going to take the LCD. I took the Hello World script that comes with the Arduino, and this is what most people see. And they can't figure out why there is no text coming up. So let's go take a look at the Hello World sketch here. And let me make this bigger because it looks small on the screen. It's probably smaller even to you. There we go. So this is what basically comes. This is the default sketch that comes from the Arduino. If you look at Crystal I2C, and it comes default. I think it comes with the address of 32 in there or something like that. No, I don't remember what it is. But anyways, it comes with an address that may or may not work. So based on the amount of emails I get, it probably doesn't work. But this is the sketch that's actually running right now that is displaying this. So obviously it's not working because it's just blank. And this is just an Arduino Uno right here with one of these displays that has the same backpack on it from YW Robot. And you can look on the back. You can see if you can see it's YW Robot or not, but it's black. It's not saying smart. So what we need to do though is figure out where is it in the addressing scheme. So what I did is I created a little program here. Let me go back over and bring it up, called I2C scanner. And all it does is it goes through all 120 addresses. And let me again bring this up. So, or make this larger so you can read it before we walk through it. So really quickly, we just set up a serial interface. You know, still get to do a lot. We start up the I2C interface using wire begin. And then I'm just going to scan through all 120 addresses, and all I'm going to do is say begin transmission. And if it comes back and it says that it end transmission, that means it got a response back, then we know something's there. And we're going to print out what address I just checked. And then we're going to finish. And every 5 seconds, we're going to go through and we're going to do this again. So here's what I'm going to do. I'm going to go ahead and upload this sketch. And we're going to go ahead and look at the serial monitor. And you can already see it's found a device, and it's at address 0x27 or 39, however you want to do it. Either one will work. So now that we found this address for this device on the line, and by the way, if you have multiple devices on the line, it'll show up all the devices because it'll go through every single address. So like if I run this on one of our boxes, we have, over a dozen chips in the I2C bus, it's going to show up all those devices. This is kind of what we use it for, is to make sure things are actually communicating back properly if we're having a problem with the board. It's kind of our testing process. But now I know the address is 27. So let's go over here to 27. Put 27 in the address. So instead of 0x32 or 032, it's 027. Oops. I forgot I did that. Hang on a second. Let me reopen this. No, it's just hello world. Not going to do that. All right, so let me find 32 here. Changing the font is what messes this up. This IDE messes up. So let me go to say, just take this. And we're going to reopen that back up again. All right, now I should be able to change it to 27, just like that. And let's see, let's go back over. I'm going to upload this and go back over to here. And we should see it come up and say hello world. All right, there it got the sketch. There it is, hello world. So it really, most of the problems people are having would be as simple as running that sketch, finding out where the address is, and changing the address. And that's really how simple it can be to fix the problems. What amazes me is how many people actually have this problem. It just boggles my mind, because I literally get things like this all the time. So hopefully this gives you a little bit more of insight as to why these aren't working. Also, go check out some of the links that I'm going to put in the show notes about the I2C if you're not familiar with it. It gives you a great background on the serial protocol. You could literally have 120 of these screens set up and communicating with them. Now, I meant to bring the other screen over here. There's this interface that we're using with this parallel interface is on all kinds of these types of boards, but sometimes they're on the side and they have like a different pin layout. So you can get these for that as well. And they work exactly the same, just the pin layout, because the screen is so, it's thinner and longer, basically is what it is. And they put that on the side. They're trying to keep it so it's not quite so tall. So it's just a different layout. It's still the same parallel interface. But there are other ones that do require all 8 bits, for example, any kind of graphic interface, things like that, which we've shown in the past, some graphic interfaces. And they're a little more complicated to figure out. But when you get this part figured out and you understand that almost all of these are using that same chip that's in there, and you run a scanner like this, then you can pretty much use, you get used to using it in this, whether it's graphic or not, the interface is the same. So you have the same problem. You still have an addressing problem because they still use I2C for their interface. This may use a little bit bigger bit range. But like I said, the I2C scanner that's going to be out there in the show notes will work with anything more than just this chip. It'll work with anything. Like we use 23017 chips, MCP 23017 for lots of things, because there's a general purpose IO chip and it's I2C based. The problem with that is it's only 3 pins as well, so their internal addressing is different. We use another one from NXP that actually is a 5-bit address, so it allows us to do a little bit more control. And actually that works out really good for us because we can put those same chips on the same board as the 23017s and use a different address in the other 2 pins and put multiples on the same address, so that one board in our code would look like it's board number 5, for example. And we would adjust the pin. We would know what the address is for the MCP 23017 plus all the other chips that are on the board based on that. So it just allows us a little more flexibility to use one address for one board. But that's very rare. And I wish more people would actually expose those extra pins, because you really are limited to 8 devices on a bus if you're only exposing 3 pins. Even there's 120 total possibilities that you can put on a bus. You're really limited by that, and you can't change those other 3 pins. So that's just something to think about. There are all ways around it. We've developed our own system now around that, so we can now support basically 4 times the number of boards that we support, 4 different buses at one time. And there's some new tricks you can do, but still it's a little bit limited. But it's a great. This is one of the most common misconceptions about the LCDs. You think you just plug them in and they go, and they aren't as simple as what you would think. You just don't print to them. You do actually get it figured out, but because they've introduced now the serial interface and the addressing, it confuses people. Where in the old days, the old days, I'll call it the old days, we used the parallel interfaces only off the PIC chips. So we didn't have to worry about addressing. We just knew what each pin was, and we made sure that it was the right stuff was on the pin when we clocked it and things like that. So it's just different. But the most common problem I have is the addressing, and I think this will hopefully help people get past that. And I know somewhere I can send people when I get the email, hey, check out this. This may help you out. Hopefully it helps everybody out. So I think that's all I had for today. Do want to remind you can watch us on the Roku, subscribe to us on YouTube. I definitely appreciate when you do things like that. Follow us on Twitter, and come back next Monday night, and we'll be talking about the Arduino Galileo. I cannot think of the name. We've been using it for a lot of things now, and there's some little quirks about it. Overall, it's a really nice board, but there's a few little quirks, and we've worked through some of the quirks, and some more we haven't worked through. But we'll talk about that next week. And if you're interested, that way, if you get one, you start playing that things don't work the way they did everywhere else. There's a reason for it, but there's ways around most of it. There's a few things. We'll get you deep into the Unix side as well, so you can see that. Talk about how you make a bootable image, which you really need to do, because if you upload a sketch to it and power it off, it's lost without a bootable image. Things like that. So there's lots of little things about it that are, like I said, a little quirky, but overall it's a very nice board. So we want to spend a whole show talking about some of the quirkiness on that, and what we've run across as far as problems, and some little hints and tips and tricks and things like that. So next Monday, come back at 9 p.m. and we'll be talking about Arduino. See you all later. For show notes for this show, contacts, and more, go to the techzen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.